Hello friends, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 14 of a unit electric charges and fields. So let's begin with the today's class. In today's class we are going to discuss about the electric field due to a uniformly charged circular ring. In previous classes we have already discussed about the electric field due to a uniformly charged circular arc. But when we were discussing that location, when we were discussing electric field due to circularly charged arc, we are discussing it for us arc at some position P. Now in this situation, we are going to discuss something like this. Let's have a look. Let us suppose this is a ring. A ring is given, and with this ring, a charge Q is given. If this charge Q is given is something like this. Let's look at this. This is the charge q that we have given it to it, and I need to find out the electric field at this position. This is point P. So I hope you understand that this is the perpendicular distance on the axis of a ring. This is the perpendicular distance on the axis of a ring. So if I assume a very small segment here, I will find out that this is the positively charged ring. For the positively charged ring, for the positive charges, electric field will be radially outward. So this is radially outward. This is the component of dE. If I make this as an angle theta, this should be a theta. So if I this is a theta, this is first component that I mention as in DEX, and the second component as in DEY. A same way I can prove that if I make a one segment here, what I could have is, here I would be having a one of the DE. Here this would be the theta. So again this would be the DEX and this would be the DEY. I just did this. I just did this to show that all the vertical component of electric fields will be a cancel out, and only I need to consider the horizontal component of electric field. That means I have written here that DEX, that should be is equals to DE cos theta. Now let's write it down. It's in K 1 upon 4 pi epsilon naught multiplied by dq by x square plus r square. It is a distance. This is the distance multiplied by cos theta. Now value of the cos theta, what is would be? It would be an x divided by this hypotenuse. It is an x divided by root of x square plus r square. So if I solve this, this is x square plus r square to the power 1. This is x square plus r square to the power 3 by 1 by 2. So if I multiply this 2, it would be an 1k into x into dq divided by x square plus r square to the power 3 by 2. Now let us integrate this. So if I integrate this, it is an integration of dq. It is an integration of dq, and when I integrate this, it would be having an integration of dq. This is the total charge on the ring. If I integrate this, it would be an q. So this is k multiplied by q multiplied by distance. It's an axial distance, divide by x square plus r square to the power 3 by 2. This is the electric field on the axis of a ring. Have you done with this? Are you sure? Okay. Now let's go through a certain applications and certain special cases. Let's say this is the ring which is given a charge q, and this would be the radius r, and this was the distance x. This was the distance s. This is all that they have provided, and I know that electric field would be equals to k q x divided by x square plus r square to the power 3 by 2. Now if distance x is much larger as compared to r, Then find electric field. This is what they ask. This is case number 1. X is much greater than R. What would be the situation? What could be the situation? Think in your mind. Look at this. This distance is very far as compared to the radius. So what we can do is, as if I am going to add this to, let's say x is 1 lakh meter, and let's say r is 1 centimeter. So what you are going to do? Will you be add this to and make a square of them and to the power 3 by 2? No, absolutely not. What you are just going to do is, you are just going to drop this x square plus r square. That means you are going to drop this r square only, because it does not have any significance value as compared to the x. So what it could be? E should be is equals to k q x divide by, this is x square to the power 3 by 2. So it should look like k q x divide by, here it is a square, this is square, so this would be x cube. Here this is x to the power 1, this is x cube, so it should look like k cube by x square itself. This is the electric field when axial distance is very large. When axial distance is very large, I can write like this: it is an k cube by x square. Can you compare this with any results? Can you compare this with any results? Because this is very important to understand the logically as well. Don't you think this is the same? Let's say this is q, this would be the distance x, and at this point you require an electric field. This is the distance x, so this would be k q divided by x square. Is it the same thing? Don't you think so? So that means if you are observing a very far point, on the axial distance, it would be having a same results. It would be having a same result. As a result, if I am having a point charge and I require an electric field at that point, can you get it? Are you sure? Okay. So now let's move to the next question, next cases. First, redraw this. This is r, and this was the x, and the charge given is q, and I am having in this electric field. It's an kqx divide by x square plus r square to the power 3 by 2. This is all they have given that. Now if they have been asked that if x equals to 0, then find out electric field. You need to do this. Do it your way. Do it on your own. What the data has been given is that if x equals to 0, then find out the electric field. First let me know that if I make an x as a 0, if I make x as a 0, which point would it be? Which point? Yes, you are right, it is a center only. So if I need to find out indirectly electric field at the center of a ring. So if E is equals to, if this is the case, if E is equals to k multiplied by q multiplied by this as a 0 divided by anything would be there, this is r square to the power 3 by 2, but this makes no sense as electric field is 0 at this point. So at a center, let's look at this. At a center, this is the center, this is the charge q that has been given. At this point, electric field at p would be a 0. Why this happens? Why this happens? Have you remember this? Let's say a charge q would be distributed something like this. Let me know. Are you agreed with this? Okay. So if I considered an electric field due to this segment, it would be in upward direction. And if I considered an electric field due to upward segment, this would be in this direction. If you considered an electric field on the right hand side directions, it would right hand side charge elements, it would be in this direction. And if you consider an electric field due to the left hand side charge element, it would be on right hand side. All would be having a same magnitude, so this electric field at point P would be a 0. Yes. Will you be able to solve this kind of things? Are you sure? Okay. Now let's move on to one question. A charge q is given. This is radius r. This is the distance x. They have said that find out electric field at point P. This is point P, and they have given that x would be equals to 3r. X would be equals to 3r. Now, how could I do this? First, write down the magnitude. It's an E is equals to kqx divided by x square plus r square to the power 3 by 2. Now just replace the value of 3r. Do it. Do it in your book. Do fast. So if you replace this, it should be k q x, it is a 3r, divide by this is 3r whole square, this is 9r square plus r square to the power 3 by 2. So that should be k q multiplied by 3r divided by 9r square plus r square. This is 10r square to the power 3 by 2. So this is k q multiplied by 3r divided by 10 to the power 3 by 2 multiplied by r cube. Here r is there, here r cube would be there. If I cancel this, it's an r square. So this is 3 k q divided by 10 to the power 3 by 2 multiplied by r square. This is the magnitude of electric field at point P as per the given data. What was your answer? Was it same? Was it? Great. Now let's move to the very important application, and in terms of the question only. Suppose what they have given is that this is the ring, and here charge q is given. This is the radius r, and this is the distance x. Now listen this very carefully. What they want to ask is find out value of x such that electric field will be maximum at that position. Go through this data very carefully again and again. Please do it. Just go through this. What you need to find out, you need to find out a value of an x such that electric field will be maximum at that position. How could you do it? How could you? What are the options? Tell me. What are the options? What you can use? What I can write is that electric field will be K q x divided by x square plus r square to the power 3 by 2. Yes, this is the value of an electric field. Now what I need is I need an electric field maximum according to that position. So what I need to do is I need to apply a concept of I need to apply a concept of maxima minima. Have you remember this? You might have studied this in the 11th class, a concept of maxima minima. In that case, what we are supposed to do is we are going to differentiate a quantity with respect to other quantity, and that should be equals to 0. Here what I need is I need an electric field to be maximum, so I have differentiated E with respect to position, so I differentiate it with respect to an x, and then I make as an 0. So this is dE by dx is equals to 0. Yes, will you be able to solve this? Let's look. So please try to solve in your book as well, and look at this video as well. So this is dE by dx, that should be equals to 0. So what I need is I need a dE by dx. This is k q x divided by x square plus r square to the power 3 by 2, and that should be equals to 0. So if I compare this, the only the term that remain should be d by dx of x multiplied by x square plus r square to the power minus of 3 by 2, and that would be a 0. Are you sure? Are you sure? Comfortable up to this? Now what you should do, this is multiplication, so you need to consider this as an u into v. So this is something like this, d by dx of u into v. So if I multiply this, this should be u into dv by dx plus v into du by dx. This should be look like this. This is u into dv by dx plus v into du by dx. Yes. Now let's begin. This is this is let's say u would be an as it is multiplied by, this is to be differentiated, x square plus r square to the power minus 3 by 2. How this is minus of 3 by 2 into x square plus r square to the minus 3 by 2 minus of 1 multiplied by, you need to differentiate x square plus r square also, this is according to the chain rule, multiplied by 2x. So this is it, this is u into dv by dx plus plus v would be an as it is, so this would be x square plus r square to the power 3 by 2 multiplied by d by dx of x, it is a 1, and this all should be a 0. This all should be a 0. So if I just try to simplify this, this is the value of an u which is x, this is the value of an u which is x. So this is x into 2x, which is 2x square multiplied by minus of 3 by 2 into 1 by x square plus r square to the power 5 by 2 plus plus this is x square plus r square to the power minus 3 by 2 plus 1 divide by x square plus r square to the power 3 by 2, and that comes to a 0. Yes, this should be a con, and let's look at the situation in the next slide, that what it look like. So this should be minus of 3x square divided by x square plus r square to the power 5 by 2 plus 1 by x square plus r square to the power 3 by 2 should be equals to 0. So this is minus of 3x square should be is equals to minus of 1 by x square plus r square to the power 3 by 2. Always I multiply this term on the next side, so that should be x square plus r square to the power 5 by 2. This minus minus gone. So the things remain would be, this is 3x square, and that should be equals to, here the term is 5 by 2, here this is 3 by 2. So this is x square plus r square to the power 5 by 2 minus of 3 by 2. So that becomes an 2 by 2, and 2 by 2 means a 1. It's an x square plus r square to the power 1. This is 3x square. Yes. So what you were interested was, this is 3x square, this is x square. So if I make this as a 2x square, that should be r square. So x square should be is equals to r square by 2. And if I make x square is equals to r square by 2, then this x should be is equals to plus or minus r by root 2. This is the location at which electric field will be a maximum. Yes. Yes. So just go through this repeatedly, and I'm sure you might be able to solve this. So one more thing, you need to remember this thing, that at plus or minus r by 2 location, plus or minus r by root 2 location, electric field will be a maximum. Electric field will be a maximum. So at that point, if you must know that if electric field is maximum, your force too will be a maximum. So electric field will be a maximum and force will be a maximum. Okay, one more thing, if they have been asked that plot the graph, this all are in continuation only, plot the graph for electric field versus distance x for circular ring on its axis. So the situation should be look like this. This is the ring, this is the radius, this could be the distance. Even on this side a distance could be there. Do you understand this? And the charge q is given. So the situation should be, uh, look like something like this. This is the location, it's a plus r by root 2. This should be the minus of r by root 2, at which electric field will be a maximum. And as soon as you moving towards r by, moving away from the r by root 2, the electric field starts decreasing. So this would be the situation. This is very very important, please remember this. This will help us a lot. Please remember this. Are you sure? Have you done this? Have you done this up till now? Any doubts? Any queries? No? Okay, let's move on. Let's move to the next. What they have given is, this is a charged ring, plus q, radius r, distance x, and this is a minus q charge. What they have asked is, on a first step, find out force acting on charge q due to charged circular ring. This is the question. How could you do this? Any idea? How will you do this? Any idea? What is going through your mind? Yes, you might thinking is F should be is equals to Q multiplied by E, while Q would be the mine and electric field will be some others. Yes, you are absolutely right. So I need to write this as an Q multiplied by electric field, and electric field will be equals to K Q x divided by x square plus r square to the power 3 by 2. This is the situation. Yes, so this should be K Q Q x divide by x square plus r square to the power 3 by 2. This would be the situation. This would be the situation. Yes, this is the force acting. This is the force acting on the electric field on charge q due to the charge circular ring. This is the force acting. Are you sure? Will you be able to solve this kind of questions? Are you? Are you sure? Okay. So let's wind it up this topic here itself. This is all about the electric field due to circular ring. Please practice this kind of question. This will help us to crack the examinations. Thank you. Have a good day. Take care. Bye bye.